Hello, my name is Andrew Prentice. I'm Professor of International Nutrition at the London School of Hygiene and Tropical Medicine, and I'm very privileged to lead a major research team in the Gambia in West Africa, where I live and work. We have a focus on maternal and child nutrition, and specifically on trying to discover next generation interventions that will help people to live longer and healthier lives. I'm privileged today to have been invited to speak about the triple burden of malnutrition, and specifically to do this in this modern era of globalization. And at the end, I hope I'll be able to show you some ways that we can think about this burden in a manner that will help us to define interventions that will help people to understand how to avoid it. So what do we mean by the triple burden of malnutrition? Look on the left-hand side, we have undernutrition. We normally measure that in children by stunting and wasting. In the middle, we have hidden hunger. So this is micronutrient deficiencies, vitamin or mineral deficiencies that you wouldn't know if you just look at a child, but are nonetheless impairing their development. And on the right-hand side, we have overnutrition. And this is usually measured in terms of the proportion of a population that's overweight, or those that are seriously overweight, in other words, obese. If you look on the maps on the bottom, we can see the burden of underweight children is very much concentrated, in fact, in India because of the large population there, and in Africa, and somewhat in Southeast Asia. And there's hardly any in the Americas. Move to the right-hand map, you see the number of obese children. Suddenly America appears large, India diminishes, Africa diminishes somewhat. We've got a large burden in the Middle East and developing burden in China. Now, all of these three dimensions of the triple burden are strongly related to the wealth of nations. So here's some data from the World Bank. You've got the gross domestic product along the bottom axis, and you've got the prevalence of stunting along the vertical axis. You'll see that there's a strong inverse association. And as you might expect, stunting is much, much less common in the wealthier nations. The same is true for what they call the hidden hunger index, which is a construct made from measurements of three different items: stunting, anemia due to iron deficiency, and vitamin A deficiency. And again, you'll see that there's this strong inverse association between the wealth of a nation and the likelihood that children in those nations will have hidden hunger. And the final graph is a moving graph, which shows the development of overweight and obesity as countries become wealthier. If you look at the date in the background, you'll see that it is moving up through the 2000s now, starting again in the 1970s. And I think this is a very graphic way to show the strong relationship between overweight and obesity as nations become more wealthy. So let's think about the really underlying origins of this triple burden. And I think we can easily describe that they have certain interrelated causes, and these affect all three of these domains. So the first is poverty, as we've just been discussing. And this is the lack of access to the most nourishing foods. Poorer people, of course, are less able to buy foods that have a high nutrient density. But it's not just poverty. People often make very poor dietary choices. And there's a lack of knowledge about what constitutes a healthy food, what constitutes a food that is going to make a child grow well and develop well into the future. And this, of course, is usually related to ignorance or lack of education, which sadly, in turn, is often quite closely related to poverty. Then we have issues around the food supply chain, and we'll come back to this at the end of the lecture. But sadly, there are certain manufacturers and marketeers who are keen to push less healthy foods on populations, particularly in certain parts of the world, and we'll show an example of Mexico. And then looking into the future, we have some serious future threats. We've got a great deal of global concern at the moment about what's happening with the war in Ukraine, which is really going to affect people's ability to buy wheat, what the effect it has on fertilizers as well. But a further threat into the future is, of course, climate change. Now, really what I want to get across most clearly in my lecture today is that there is a single interlinking factor that can explain all three of the domains of the triple burden. And that is a low nutrient density of foods and diets. Let me explain this a little bit more clearly. So for undernutrition, we have diets that are low in energy and low in protein. I'm going to describe this in much more detail in a second. In terms of hidden hunger, the same foods have low vitamin contents and low mineral contents. And then paradoxically, perhaps, on the right-hand side in terms of overnutrition, we have foods that have low nutrient value, but very high energy. The first of the triple burden we'll look at is undernutrition. Many of you will be familiar with this graph here, derived from analysis of 54 demographic health surveys in low and middle income countries. Now, a well-nourished child should grow across the horizontal black line at 0 for the Z scores for the World Health Organization. What happens, however, is that both in terms of weight, but even more so in terms of height, children in these countries really fall away from the 50th centile of growth, so are becoming very stunted. Now let's ask ourselves the question, what can we do about this? You would think, of course, that we need to feed these children better. So the World Health Organization has developed recommendations for infant and young child feeding, IYCF. And many people have done very carefully conducted randomized controlled trials where they've tested the impact of getting mums to adhere to the IYCF guidelines and to feed their children better. Let's see what the result of all those trials put together is. Unfortunately, it's a huge disappointment. The good news is that there is an impact. The bad news is that we have not really rescued a great deal of the deficit that has occurred by 2 years of age. So this is a real challenge, and there are many answers to why this is the case. So let's look at this particular study from Bangladesh, which was really excellently conducted. It was a trial where they fed foods of different energy and for different numbers of occasion each day to breastfed babies and measured how much they consumed. On the left-hand side here, we see the 3 different energy densities, the highest density in the black column at 1.5 kilocalories per gram, going down to 1 kilocalorie per gram and half a kilocalorie per gram in the gray column. And you'll see that the 3 clumped columns are 3 meals, 4 meals, and 5 meals per day. Note that as children are fed the more energy dense diet, they do reduce a little bit the amount that they consume. But in spite of that, because there is such a big difference in the amount of energy in what they're consuming, then children are obtaining much more energy. And remember that it will be much more protein as well if they're fed a more dense diet. So the overall intake is larger with a higher nutrient density and with more meals per day. Now, of course, these are breastfed babies, so you might ask the question, well, if you're feeding them a lot of extra food, maybe that's going to impair breastfeeding. And indeed, it does a little bit, but not very much. So the energy-dense weaning foods slightly reduced the breast milk intake. And also, if you feed children more often during the day, it reduces the breast milk intake. But if you look at the scale there, you see that this is not a very large effect. So, in summary, in these breastfed babies, by feeding them more often during the day, so going from left to right here, and with a higher, in this case, energy density, but the same would be true for nutrient density, we can get a much greater intake into the children with frequent feeding and a high energy or nutrient density. So that really tells us a lot about why children are not growing so well in low-income countries, where they may be spending a lot of the time, these are slightly older children, but the same will be true of the younger ones, consuming a thin, gruely porridge made from rice or millet or maize or whatever. And it simply does not have sufficient density of protein, energy, and nutrients to allow them to grow properly. Next, we turn to hidden hunger. I want to use the example of my favorite nutrient that I do a lot of research on, which is iron and iron deficiency. So here's the recent data from the Global Burden of Disease, which shows that in fact, iron deficiency is the most prevalent of all micronutrient deficiencies and has a huge effect on what is called lives lived with disability. And each of those countries with a light beige color there, those are countries where iron deficiency is the greatest contributor of all to lives lived with disability. If we look in my own country, Gambia, you see on the left-hand side, the highly anemic kids, the blue ones are boys, the pink ones are girls. Those columns show the hemoglobin levels, and we compare them to the African American 5th centile, which is really a poor level already, but our kids in early life are much below that. And in terms of a national survey, we also find high levels of anemia and iron deficiency. So why is this occurring? And the answer, of course, is that iron is concentrated in certain foods, and those foods tend to be difficult to get and also very expensive. So, of course, we all know that meat is going to contain the best source of heme iron and very concentrated. We can see on the left-hand side there seafoods, which are also a very good source. Eggs are a good source. Nuts are generally a good source. And these are hard to get for poor populations. So the green leafy vegetables shown there are also good sources of iron, but unfortunately contain chelating agents, which make the iron much less available. I just want to finish this little bit by showing you this rather remarkable data in terms of iron deficiency from young children that we study in the Gambia. Let me show you first of all that the the light green boxes are the reference ranges from a normal American, European, or whatever child. If we start with pregnancy on the left-hand side, those green diamonds are Gambian women, and they do pretty well in terms of their serum iron levels. At birth, the yellow and the pink diamonds there and the blue one, they're not too bad at all. But during the early period of breastfeeding, and this is often exclusive breastfeeding for the first 6 months, iron levels plummet to really very worryingly low levels. And that continues till about a year of life, which then, as children move on to the adult diet, starts to recover, as you can see from all those green diamonds on the right-hand side and up into adulthood. So this is a real challenge. Of course, we don't want to undermine the concept of breastfeeding and exclusive breastfeeding, but the truth is that breast milk contains very little iron, and these children are becoming highly iron deficient. And this gives us a really good example of how hidden hunger can occur. Finally, we turn to the issue of overnutrition. And incidentally, it's such a shame that it seems impossible for any country to go from being undernourished, having lots of stunted and anemic children when they're poor, as they move through the economic transition. It seems almost impossible for any country to stop the pendulum in the middle and have a really healthy population. It usually moves right over to the right-hand side, and they end up having a lot of overweight and fat children. And Mexico is, a wonderful example of this, or I should say a terrible example of this. It's hard to pick out a single lean person in this random picture. And many of the kids are suffering from severe morbidity in relation to the fact that they are extremely overweight. This is not good news for a young child. Now, what's going on here? Well, we've been doing a lot of experimentation when I was working in Cambridge and leading a group on energy regulation, where we tried to understand how the body regulates its energy intake. And we would do many experiments to volunteers like this man here, where we would covertly manipulate the content of the diet, and we'd give them foods and then say, just eat however much you want. And we would weigh them and we would measure their body composition and their energy expenditure very carefully. I just want to show you one graph that emerges from that kind of work. So here, what we've done in a number of different studies, each color indicates a different study. We have secretly changed how much energy is in the food. So let's say we give them spaghetti bolognese or something, but one version of it has very little fat and energy, and the other has a lot of fat and energy. And the take-home message here is that as you increase the energy density of the diet, the energy intake increases. In other words, people do not notice. There's no normal biological regulatory mechanism that tells them, I'm overeating here. And so if energy density is high, people will overeat. And that, of course, is what's happening with so many of the modern foods, which are extremely highly refined and contain very high energy contents. We did this rather fun little study where we just simply took the data off websites from 3 well-known fast food outlets and plotted the energy density compared to the average energy density of the UK diet, and compared on the right-hand side there to the energy density of a Gambian diet. What you see from this is that you cannot even enter one of those outlets without being confronted by food that has an exceptionally high energy density. And based on what I've just told you, the fact that we as humans are not able to detect that, then people are going to spontaneously overeat and gain weight. And the driver of energy density is almost always fat. So here's a graph of energy density on the x-axis and fat content on the y-axis, and divided into fast foods at the top, supermarket ready meals in the middle, and then some Gambian and healthy choice foods down at the bottom. You see there's this very strong relationship. High fat is the primary driver of energy density. And that is why so many of our population are getting into difficulties with overnutrition. So let's come back really and consider all of these three together. And my thesis today is that there's a single factor that can explain all three domains of the triple burden of malnutrition. And this is the low nutrient density of foods and diets. Just to review for one final time, undernutrition is bound to be driven by kids having highly bulky foods which have a low protein and a low energy content. Hidden hunger is caused by low vitamins, low minerals, low iron intake, as I illustrated. And overnutrition is spontaneously driven by the fact that we're poor at recognizing when foods contain a low nutrient content, but a very high energy content. And I think if we put these three thoughts together, or this single thought together as an explanation of the three domains of hidden hunger, then this really makes sense and will help us to define both educational interventions for people to understand the problem better, but also governmental or paragovernmental interventions that can try to change the food supply such that we can avoid the triple burden of malnutrition. With that, I say thank you for your attention.